Hello again, LinkedIn. This is Gary Jarena. Today we're going to continue our series called Digesting Drawings. We're looking at a 115 kV AC elementary. So when I start digesting drawings, one of the first things I'll look at when I grab a new drawing to digest is I'll look at the lower right-hand corner and I look for this PE stamp, make sure it's there, it's valid, make sure that the name on the drawing and the drawing number and the revision matches the transmittal. Then I'll come over here, look at the date, hit it, and make sure it's IFC, issue for construction, Rev 00. See, we're using 00, and that's confirmed on the transmittal as well. And it also lists the names and the dates. That's another verification because on the transmittal it will have this date. I also look at the legend. It tells me what the symbols mean. For example, the square with the X means it's in a remote device, so that's important to understand. That helps you identify where these things are located and how to find them in the drawing package. So pay attention to the legend. First thing I'll look at on a 3-line AC elementary is I pay attention to the phasing. So I notice it's 1, 2, 3 here. 1 is this phase. They're calling that one phase. It could be A, it could be C, but we're going to call it one phase. And then one phase comes over here, connects. If you zoom in, there's a connection point there. It connects and it goes to the transformer on phase 1. We'll follow phase 2. Phase 2 goes to 2. Phase 3 goes to 3. Okay, so that all looks good. And the other thing I look at is the breaker and the orientation of the breaker to the poles. So you'll notice this is the breaker, 3B62. This is the mech house, which is the control box, the breaker control box. Notice it's orientated on the side of the breaker. So if you're standing right here and you're looking at the mech house, which is the control box of the breaker, on your left should be pole 1, and on your right should be pole 2. And of course, you can verify that with the nameplate information on the drawing and the nameplate information on the door at the breaker. So I notice here on pole 1, on the bus side, I have 2 CTs stacked. This one is on top of this one. And on pole 2, I have 2 CTs stacked. So this number represents the pole, and this is the physical top of the pole. So from this point to this point is either a whip or a rigid bus. More likely it's a whip from here to here, and then a whip from here to here, and then this is all rigid bus. Or it could be a whip from here to here and then rigid bus. This is the MOD, motor operated device or disconnect. This dash line means it's gang operated, and this MOD is called 3B68. So when I go out to the yard and look for this MOD, I'm looking for 3B68. When I look at the breaker, I should see a label that says 3B62. You can verify these poles 1, 2, 3, 4, 5, 6 on the wiring diagram and the breaker elementaries to make sure that the poles are correct in reference to the CTs. Then we'll follow down. We'll just pick this path here because it's drawn. This one we would have to go to this drawing. This dash box means it's located in another location. It tells you right here. JB, this junction box. So that's junction box 3B62 CT junction box. Another clue that tells me this is in another location is the square with the X. And the legend says the square with the X is a remote device. So from here, as you notice, this is 3 up here. It goes to this CT, H1. That's what the polarity mark means. That's H1 of the CT, and that's X1. We'll follow X1 out. It goes through this terminal block, shorting block, PK1. Then it goes to this terminal block 22. It comes out as Charlie 3. It goes into the control house, panel 110, termination point Lima 82. So if I go to the drawing for panel 110 and I look at terminal block Lima and I go down to 82, I should see a wire that goes from this point to this point and labeled accordingly. From here, it goes into a test block, which is a shorting block. These are test fingers. So I can lift the fingers and short the current around the CT. It comes in on the bottom of the test block, 20, and it comes out the top, goes into the relay, into the ICX winding of this 3B62 relay, and it's an SEL 451 breaker protection relay. It comes out of winding ICX, Zulu 12, goes back to the top of the test block, 17, comes out the bottom of the test block, 18, and goes to Lima 87, which is also a terminal block in panel 110. Now, all these numbers can be verified on the wiring diagram, but this elementary shows how it needs to be wired and needs to be proved. You need to prove that this path from this CT goes through all these points and into the test finger as drawn, comes out and goes back to the terminal block. And I would just look at each one of these, just so in my mind it makes sense. I have to first go through a test finger, then into a relay, out of the relay, into a test finger, and back to the terminal block. Okay, I'm going to look over here and make sure all this makes sense. Okay, everything looks good. I'm noticing here, this is panel 110. This is panel 110. This is a 451 relay. This is 451 relay, but they're two different relays. So panel 110 has two 451s. This one's 3B62. This is T462. We also have a set of CTs right here that are providing a current contribution to this bus relay, bus differential relay. It's called 83-115/87BB. Bus for the B. There's also 87BA, but that's another relay. But this one's 87BB, and it's a GE relay B30. A B30 is a multi-lens bus differential relay. Same thing here. I'm going to look at where it comes into panel 125. 125 Lima 80, it goes to the test fingers. It goes into the coil in the relay, comes out to the same set of test fingers, different number, and then continues on. It may end here or it may continue on. One of the things I look at is a single point ground. CT circuits need to have a single point ground. Don't confuse this ground with this ground. They're not the same. So you notice there's nothing connected to that. This is your single point ground. It's located on Lima 83. So when you're proving your CT circuits, you need to identify this, because that wire you'll have to lift and test and land and test. Over here, where's my single point ground? It's right here, Lima 123. Over here, where's my single point ground? It's right here, Lima 83. Okay, I notice here on this drawing, I have another single point ground, but this says it's from T362. So I know T362 is another breaker and it has its own set of CTs. So that breaker with its own set of CTs, the single point ground for that breaker is right here. Okay, so that's me digesting of AC elementary. I hope this helps you, and that's it for this session. Have a wonderful day.